For number 6, part C, I said in the previous video that you could use your answer from part A to get your answer for this f of g of 1. You could use your answer from part B to do g of f of 3. Or you could just do them step by step independently. Here's why I would advise that you don't use your answers from part A and part B. If you're using your answers from part A and part B, you're basically banking on doing those correctly. So what if on this part A, what if you forgot to do this x minus 4 times x minus 4 correctly? And what if your answer for part A is wrong? And then you use that answer in part C, that would make you get another question wrong. So I would advise in part C that you ignore what you got from part A and part B and just do these problems independently. So f of g of 1 means that you need to start by doing g of 1. So plug 1 into the g function. So that would be 1 minus 4, which is negative 3. Then do f of that. So we're going to take this number and plug it into the f function. So negative 3 squared plus 5, negative 3 squared is 9, and 9 plus 5 is 14. If you do this independently of part A and part B, you could potentially get part C correct, even if you got part A incorrect, which I think it's worthwhile to do a little bit of extra work to ensure that you're doing the problem correctly, regardless of what you got on a previous problem. For g of f of 3, they want us to start with f of 3. So you're going to take 3 and plug it into the f function. So 3 squared plus 5, 9 plus 5 is 14. Then do g of that. So then plug that 14 into the g function. 14 minus 4 is 10. Question number 7. Use the horizontal line test to determine which of the following functions have inverses. And I honestly don't know if we touched on this in the notes or not, but do you remember the vertical line test? If I asked you, hey, is this a function? And you do the vertical line test and the vertical line would touch 2 points and say, oh, nope, that is not a function. Well, because when we take a function like a parabola, we find the inverse of it, we end up reflecting it over this line, and that would make it look kind of like this. This new function, after we reflected it, would not pass the vertical line test, and this would not be a function. So we kind of save ourselves some time by doing the horizontal line test. If a horizontal line touches more than 1 point, then the inverse is not going to be a function. So they're saying determine which of the following functions have inverses. They're asking which of these functions are going to have inverses that are functions. And it's kind of weird because number 1 is included and number 1 isn't a function in the first place, but whatever. So use the horizontal line test basically means draw horizontal lines through here and see if they touch more than 1 point. So in part A, a horizontal line touches 2 points, so not that one. In number 2, a horizontal line, no matter how many horizontal lines you draw in here, each horizontal line is only going to touch 1 point at a time, so yes for 2. 3, a horizontal line touches 2 points, so no. So 1 is a no, 3 is a no. 4, you could put an infinite number of horizontal lines through here. Each horizontal line will only touch 1 point at a time, which means that yes, 4 is good. So 2 and 4 are good. 2 and 4 only. Okay, question 8. This one has 3 parts. It's the finding inverses. So there's 3 steps to finding the inverses. Step 1, change that f of x to y. Y equals 2x minus 4. Step 2, switch the x and the y. Actually, we kind of have we'll just combine some steps. Get y by itself. So we're going to add 4 on both sides and then divide everything by 2. So we have x plus 4 over 2 equals y. The last step really is to change this y back into this symbol, f negative 1 of x, but I have already put that in as a label, so all you have to do is type this thing into that field. Now, here's the important thing with this. You need to start with this button. This is the fraction button, and when you click that button, it will give you that fraction line. You can click on the top and type in x plus 4. And remember, you can use your keyboard as well. I'm just showing you how it is on this math keyboard that they give you. And then you just click on the bottom and click 2. X plus 4 over 2. If you try to type in x plus 4 and then hit this fraction button, it's going to throw everything out of whack. So you need to hit the fraction button first. So you might want to make yourself a note. Fraction button first. Okay. Part B, find the inverse. Step 1, change that to y equals x cubed plus 9. Step 2, change the y to x, change the x to y. Then we need to get y by itself. So we need to subtract 9. And to get rid of this cube, you would do a cube root. So we end up with the cube root of x minus 9 equals y. Okay, on this little keyboard thingy, the cube root would be this button right here, the little n square root button. And that is going to give you this little symbol thing, and it'll have a cursor space here and a cursor space here. So in this first little spot, you would type in the 3, and then underneath, you'd click your mouse to be underneath the radical, and you'd type in x minus 9. And remember, you got the x right here, or you can use your keyboard. Does not matter. Part C, find the inverse. First step, this is y equals x minus 2 over 6. Switch the y to x, switch the x to y. Okay, this one's a little bit weird. The first thing we need to do is get rid of the divided by 6. We do that by multiplying both sides by 6. So we have 6x equals y minus 2. And then we would add 2 to both sides to get 6x plus 2 equals y. So that 6x plus 2 is what we're entering. This one should be the easiest one to type in. 6x plus 2. And that's it. If you have any questions, email me, let me know. I'm here to help you.